Hi, I'm Karan Singh, Senior Architect at Red Hat. In this presentation, I will walk you through Data Engineering Jumpstart Library, an end-to-end functional use cases to jumpstart data engineering productivity on top of OpenShift and Kubernetes. The Data Engineering Jumpstart Library provides data engineers with some sample working solution to familiar industrial problems using a modular pattern approach. This is all deployed and developed on Red Hat OpenShift. In this, data engineers will get a GitHub repository where you will have all the workshops and guides that can help you deploy a specific solution on OpenShift. The repository contains functional demo, some Python glue code that you can always change, some OpenShift YAML files, which will help you deploy the components and tools required for the demo to work on. This also contains some sample data and some sample pre-trained machine learning models. For the enthusiasts out there who are interested in automation, we've also packed in some automation deployment scripts, which will help you deploy these solutions really quickly. The intention is that you will get to do some data intensive work on top of Kubernetes. So these are some solutions or examples for that sake that you can deploy on it. So it's always better than a hello world YAML file or pod or container running on OpenShift. You'll get to work on a lot of different tools using this Data Engineering Jumpstart library. The overall vision for the Jumpstart library for at least for this year is to cover multiple different industrial verticals, try to identify some use cases and how we can solve it using the technology. For healthcare industrial use case, we have identified X-ray diagnosis. For government industrial use case, we have identified smart city and green city. And for industrial, right now we have completed factory floor predictive maintenance use case. We are also working on some more industrial vertical use cases like financial and oil and gas, but those are yet to be worked on. Typically, we start with a business problem. We identify the business problem and address it by building an end-to-end solution. For healthcare, we have identified a few business problems like how we can help faster pneumonia diagnosis, how to focus practitioner time, and how to increase case throughputs. So these were some initial business problems we have started with and developed the solution. On the other industrial verticals, which is government and smart city and green city, we have identified how we can reduce the congestion, how we can reduce the pollution in the city, and how we can locate some wanted vehicles. For industrial use case, we have identified some business problem, which were how we can reduce factory downtime, how we can improve the product quality, and how we can reduce maintenance cost. So with these problems as our base, we built a solution on top of OpenShift using lots of different tools. So why we are working on different variety of industrial problems and industry use cases, we have identified one thing. There is a very common pattern that emerges, which is across the use cases. So these are some modular reusable patterns that we see in each solution. So for example, triggering Kafka event when an object is ingested into an object storage, that could be an event, and or maybe triggering a serverless function as soon as the Kafka event is created, right? So these are some modular examples of some modular patterns that we have seen, which are common across industrial verticals. And we are pretty sure that as we keep on adding more use cases, we will see this modular patterns coming out that we can deploy across different use cases. So for the sake of understanding, you can consider these as Lego bricks. You can combine, mix and match various different model to build up a solution that works for you. I'm going to describe these models later in this presentation, so just hang tight with me. So Next, we'll go through a smart city data pipeline demo, which represents an edge-to-core machine learning solution on top of OpenShift that uses Kafka and lots of different tools. Let's understand the business requirement for smart city and green city. As I mentioned before, the requirements were how we can reduce the congestion, how we can reduce the pollution, and how we can locate some wanted vehicles and notify government official in case if there is a stolen vehicle. And maybe how we can charge a dirty vehicle or extra fee for a vehicle that does not met emission standards. And so yeah, this is a fictional situation or scenario that we have created and have built up a solution on top of it. What you're going to see here is we have solved this using multiple different open source and open source technologies like Kafka, Ceph, Superset, Open Data Hub, obviously Kubernetes, because this is all deployed on Kubernetes and OpenShift, and using Ansible and Trinio, etc. So I call this as the smart city green city tech soup. So in the next coming slides and my demo, you're gonna see how these multiple technologies are working together and making sure the data is all on Kubernetes. Before we go into the demo, let's understand the solution design part one. So this use case comprises of an ultra low emission zone where we have multiple different cameras installed in a certain boundary of a city. So for here, we have chosen London because in London there is a ultra low emission zone, and on in each station we are having multiple cameras which are taking and capturing the live feed coming from the traffic. We are recognizing these all these cars that are passing by these toll stations, and as soon as the car moves from the toll station, we are capturing its number plate and getting the string out of it, appending some metadata like timestamp and location to each event, and transmitting that from the edge location where we have multiple edge locations onto the core data center for more compute and analytics. So that's the part one of the solution. The part two is how we can collect the data from the edge or multiple edge locations where we have Kubernetes or OpenShift deployed on multiple edge locations, and moving this data from the edge to the core, and on the core we are doing some machine learning operations, and we are retraining the model as the data is coming into the system to improve the efficiency of the model, and then deploying back the upgraded model or the new version of the model onto multiple edge locations. Right, so that's part two of the solution design. Overall, it's look like this. There are multiple OpenShift or Kubernetes edge locations spreading across the city of London, and we have multiple cameras looking for the cars which are passing by the toll stations. And here we see our first pattern, which is inference at the edge. How we can deploy a machine learning model on Kubernetes that will do inferencing at the edge to detect the license plate number and recognize it. So as a new image enters into the system, we are doing an LPR model, license plate recognition model, which extract out the boundary of the image that has the number plate, and then passing this sub image into an optical character recognition model, which produces a string of the license plate. And once we have the string from the license plate, we are adding some more metadata like location, metadata, and timestamp to it. So once we have got the string of the license plate from the image itself, we have to move the data from multiple of these edge locations onto the core locations. So we are using a Kafka producer, which is deployed on the edge location, and this Kafka producer is putting data onto the local Kafka topic running locally on Kubernetes. OpenShift, right? Here we see another pattern, which is how we can efficiently move data from multiple edge locations onto the core data center. So here we are using a Kafka functionality called as Kafka Mirror Maker, which helps you move data from a source Kafka cluster to a destination Kafka cluster. In our case, we are moving the license plate number strings and as well as the additional metadata in the form of JSON from source Kafka cluster to the central Kafka cluster running again on OpenShift. So now once we have the data onto the central core location Kafka cluster, we can do lots of interesting stuff with this. We can create our own custom consumers that, with some business logic like, hey, I wanted to, in real time, I wanted to detect the lost vehicles and notify the government officials. Or maybe I want to store this data for long-term preservation onto an object storage. There we make and use a tool called as Secker, which is an open source tool, which is a Kafka consumer that helps move data from Kafka cluster and store that into the relevant format that you're looking for into an S3 object storage bucket. Here we are using OpenShift Data Foundation, which is basically Ceph, using to store all the S3 objects into the bucket, which can later be used as a data lake, or how we can read data directly from tools like Spark and Presto from the object storage. Finally, once we have collected all the data into the Kafka or a database or a S3 object storage, we need to do some analytics and reporting, like fee calculation, real-time reporting. So for this, we are using Starburst Trinio, which is Presto, which was the old name. So it is a distributed SQL query engine that can read data from multiple heterogeneous sources. So at the same SQL query, it can read data from a PostgreSQL database at the same time from an S3 object storage like Ceph or ODF, OpenShift Data Foundation. Once this SQL engine produces runs some queries, we can use tools like Superset and Grafana to build out rich analytical dashboard that could be used for the business people. So this is how we have, as you can see, we have started from a business problem. We have decoupled that into multiple modular patterns, and we have implemented it using several open source technologies. Let us now go into a demo where you can see all of these things in running. I'll switch to my my other terminal. So first of all, this is the open source GitHub repository for data engineering Jumpstart library. So I invite you all to take a look and try to use it. If you see any problems, please open up some issues and I will work on it. So yeah, it's pretty simple. Red Hat Data Services / Jumpstart library is the repository where you can find all these demo and the sample code base. I'll switch to my OpenShift environment. So this is a pre-configured OpenShift environment. We have all the tools and the sets are deployed on this cluster. This is a project in OpenShift called a Smart City, where you can see I'm running multiple Kafka cluster. I'm simulating edge and core into the same environment because I do not have it's not for real. We don't have deployed it on tens of location in city of London. So it's a mock-up. So we are running multiple Kafka clusters, and then we are also running several services like Grafana and ODH, Secker, Superset, and how are we deploying multiple Kafka consumers, image server generator. So this is all pre-configured environment, and if you're interested, you can quickly jump into the developer dashboard, where you can see there is some serious computing and data running on OpenShift. Lots of containers here, lots of services here, lots of moving parts here, right? I'll switch to how this will look like. So this is the Smart City ultra low emission London dashboard for people who are, managing the traffic or central location where from where they want to see how this looks like. So this data is coming in real time at the moment as I speak. So images are coming into the system, into this hypothetical situation that we have created here. Images are coming here, and as you can see in from this panel, and there is an object detection going on, which is detecting the number plate of my vehicle, and kind of detecting the make and model of the car and owner. But yeah, this is all fake data. So yeah, this is a panel where you can see, the heat map of maybe, what is the most popular station in my city. Let's say station A is getting most of the traffic, right? And these all black boxes are simulating the edge locations where OpenShift and Kubernetes are running, Kafka clusters are running, inferencing is happening at the edge, and they're all sending data onto the central location. So yeah, I have another nice panel to show you, which is like CPU usage and how does it look like. So this is a GIF which explain, okay, we have edge locations and core locations, and we have smart city inferencing happening at the edge as data comes into, and via Kafka the data moves to the core Kafka cluster using Mirror Maker, and then from Kafka the data moves to Ceph object storage using Secker. And once the data is in object storage or maybe a database, we can use tools like Starbus Presto to analyze and do some querying on this data. Let's move on to the second dashboard that I want to show you guys. Is this is a superset Apache superset dashboard, which is a part of Open Data Hub. Open Data Hub is a pretty interesting project for all the data scientists and data engineers out there. Go take a look. There are a lot of tools and a lot of bindings available. So we have deployed Open Data Hub operator on OpenShift, which provides us the capability of using superset and Grafana and Presto, and there are so many tools other than this available. So this is again a live reporting dashboard. Gone are the days where you wanted to run batch processing queries over the weekend or maybe over the month end, year end, right? With Kubernetes, with data on Kubernetes and how different tools are working on Kubernetes, this is all possible to do this in real time. So this is a just a sample chart or sample panel of the same data sources that we have collected here. So if I refresh this one, we'll see some numbers should be changed. Yes, so number got changed. So we have got some toll fee collection of 392 pounds, 392,000 pounds. Total pollution fee collection is like 182,000. Again, this is all baked up number. I have a generator which is generating this random data, but you got an idea, right? We are capturing the data and we are simulating this traffic, and we are providing, we are calculating fees on the vehicles. So the idea here is to show you that these tools are available and help you take some decisions based on the data. And Kubernetes is of course the data plane for this. You can deploy these tools and make sure that your business is taking some intelligent data-driven decisions. And Kubernetes is of course ready for this. You should be deploying some data-intensive workload on Kubernetes, and that's the reason we have with Data Engine Jumpstart library, we are trying to make sure that you should have a variety of use cases or anything which is better than Hello World YAML files on OpenShift or Kubernetes. So please take a look at this Jumpstart library project. You will find it interesting, and thank you so much for your time today. And yeah, cheers. Have a nice day.